basically, if you just want to fire the gun, all you've got to do is turn on the gun and it's ready to go. Load a pellet. I got the single shot tray in there right now. Close it, pull the trigger, fire it, you're off and running. If you want to program it, you need two things. You're going to need a chronograph, and you need to know how much air is in the cylinder after each shot. Now, right now, as you can see, it's got 230 bar in it. The gun doesn't measure the air pressure in bar well, I mean it does, but in terms of its programming, it uses something called R values. In fact, I actually use R values instead of bar when I use the gun because I'm always tweaking it. So in order to get into the menu for programming, it's really simple. All you got to do is hold the trigger down, if you can see me doing this down here, and turn on the gun. And while I'm holding the trigger down, you'll see it cycle through all the different menus. And if I wanted to stop on any one of these things and change the settings, I just got to let up on the trigger. But I'm just going to hold it down. I holded it down through all the menus there. So I turned the switch off. I didn't change anything. What I want to do right now is I want to change what it shows me on the screen. So I'm going to hold the trigger down, turn on the gun, and wait till it gets to the setting I want. LCD extra info, so I let go right there. Okay, now the extra info is off. I'm going to turn it on, and to turn it on I click the trigger. So now I get the pulse widths, which is not that important for me to know, I guess. What I really want to know is the RP values here. That's the pressure values that the Heliboard uses. So I'm going to hold the button down till it's saved. I'm going to turn off the gun and turn it back on, and now you'll see instead of 230 bar, I've got 838 or 78 R values as the pressure slightly changing inside the thing there. It's also given me a number of 1,802, which is the think of this number as like the hammer spring tension, even though it doesn't change the hammer spring tension because it's electronic. The higher this number is, the harder the hammer hits the valve, and the lower the number is, the lower value this number hits the valve. And so what I'm going to do is I'm going to actually check my power settings, or I'm going to check my shot screen at power setting 9. It's one of the few that I don't shoot very often. It's one that I'm not real confident in. So I figured I'd just, in this example, do that. And so right now I'm on power setting 4. So let's change this to power setting 9. So I turn off the gun, hold the trigger on, down, turn the gun on again, and you'll see the power level setting. So I'm going to let go of that. Now I'm in the set power level. So now each time I click this, the power setting changes. I want to be power setting 9. So I'm going to hold it down. It's saved. Turn the switch off. Now when I turn on the gun, it says I've got 42 shots at power 9, and you can see the 2664, the pulse width, that's what that's called, has been raised up, meaning it's going to hit the hammer much harder. And these are the values that you end up programming inside the gun. But you need to correspond them with the correct pressure. Because as the pressure drops in the air cylinder, your hammer doesn't need to hit the valve as hard to keep a consistent shot string. Alright, so I'm going to turn this off, and I'm going to actually, before each shot, I'm going to write down the R value. Then I'm going to record the velocity, and I'm going to shoot the entire shot string. And then to save time, I'm going to come back and then show you how to do the editing. So I'm just not going to record the shot string here. So I finished shooting the shot string, and I was surprised. It was better than I thought it would be. Here you see the third slide of the shot string that I made. And what you're looking at is I had an average velocity of about 855 feet per second, which was 29.44 foot-pounds of energy, a little lower than the 30 I was hoping for. But the standard deviation was a little bit over 4, and that was an improvement of the last shot string I shot at this power level, which had it a little bit over 6. So also important is I actually got 55 good shots instead of the 49 that I was expecting. So all around, it worked out pretty well. I'm going to switch to the first slide here. And what I want to point out first on this slide is you'll see is as the shot number, goes from 1 to 2 to 3 to 4, the pressure is dropping in R values, just like you'd expect. Now what the gun does is it sets a reference point at specific R values. So it starts up at 880, which is an overfill. Then it goes down to 840, and every 40 R values that the gun drops, the gun sets a pulse width baseline, and it figures out what pulse width it should be in between those values. And so I went ahead and highlighted those pressures in red to make them easy to see. And so at 840, which the gun wasn't quite at, it would have been really nice to have gotten that first shot recorded, but I forgot to turn on my chronograph because I'm a moron. But if we look at the second shot, it was high. It went 871 feet per second, and our 30 foot per second goal for this pellet would have been 863. And so that's high for that's about 8 feet per second high. What I've found is that higher power settings, the pulse width and the foot per second difference is not a 1-to-1 ratio. In other words, if you want to raise the gun's velocity by 1 foot per second, you need to raise the pulse width by either 1.5 or 2 times that amount. So in this case, since we want to raise the feet per second by 8, if we take that by 1.5, we get 12. So I'm going to go back in and program the gun at 840 to have a pulse width that's 12 higher than it is currently. Now if we look at the pattern for the next 2 reference points, at shot number 5 and shot number 10, which corresponds to about 800 and 760, you'll see that the velocities are really close to what we want them to be. They're really close to the 863 feet per second. So when I go back in to do my programming, I'm going to leave those 2 values alone. If you look down at shot number 15, you'll see that the velocity seems to be falling a bit there. It seems to be a little bit low, especially around the values there. And so I wouldn't mind bumping the velocity up when the pressure gets to that point. And since those values seem to be about 10 feet per second too slow, I'm going to raise the pulse width 15, which is about 1.5 times. At lower power settings, it's more of a 1-to-1 ratio, but at the higher power settings, the pulse widths aren't quite as powerful, I guess. They don't make quite as much difference. Then if you look down at shot number 20, which is at the 680 pressure value, the velocity is about 10 too slow. So when I go back in and do the programming, I'm going to actually bump that pulse width up 15. So on this next slide, we see some more of the data. Looking at shot number 26 and the values around it, we see that the values around this are about 9 feet per second too slow. So at the 640 R value, I'm actually going to raise the pulse width up 12. And then, if you look down at shot number 31, which is about the 600 value, every 40 R values, there's a new input that you put into the Heliboard. The velocity is close, maybe a little bit low, so I might try to fine tune it by raising the pulse width maybe 5 right there. I mean, it probably doesn't need it, but I'm probably going to raise it 5 just to make sure I can fine tune it as close as I can. Then on shot 36, where the pulse value is really close to the 560 input point, the velocity seems lower than it should be, so we're going to bump it up 15. And then at shot 41, where you see it's around the 520, it seems even more low, so we'll bump that one up 15 as well. And so next we'll go to the third and final slide. At shot 46, we see that the pressure in the gun was 481 R, and that resulted in a velocity of 854 feet per second. And so that's a little low, so we should probably bump that value up, and I figured I'd try maybe bumping it up 12. And then when we got to 440 R down at shot number 52, the velocity seemed to be on the rise there a little bit, and it seems pretty much close enough, so I figured I'd just leave that value alone. Now, armed with all of this data, we need to go back into the gun and actually change the values, and I'm going to show you how to do that next. This is a spreadsheet of all the pulse widths at each value that the gun is currently programmed for. If you look at over here on power setting 9, I've got it kind of a red colored under setting 9. That means I don't have very much confidence in it. I don't shoot power setting 9 very much. It's one of the reasons I'm doing this video. When I want higher power, I tend to shoot power setting 10, and I'm much more confident that that's going to be closer to 33 feet per second, and that it's going to have a fairly good, fairly small standard deviation between the shots. So these are the values that are currently in the gun, and so what I'm going to do is I'm going to, for example, at 840 here, where it was 2,670, I wanted to bump that down 12, so I'm going to actually go into the gun and change that to 2,658. The 800 and the 760 values were okay, so I'm going to leave those alone. I'm just going to change the values in the gun to make it hopefully a little bit more close to 30 foot-pounds of energy, and to hopefully lower the standard deviation the next time I shoot it. Okay, so now that we have all of our data and we figured out exactly how we want to change the programming on the gun, let's look at how you actually change the programming. So to do that, again with all the other times, to enter the programming stages, you hold the trigger down, turn the gun on. And you're just going to keep it held down until you get to the programming stage, which is this next one right there, Power 9 calibration. So now I let go of that button and I'm on Power 9 calibration. This tells you the R value. This tells you the pulse width that is currently programmed in it. Every time I click the button, I move up 40 R values, which is a place where I can program it. And the first one we wanted to actually change is 480. So we're going to go all the way up to 480. Here's 480. And we wanted to bump that one up 12. So I hold the button down. See the 9 came up, that's when I know to let go. We're going to bump that up 12 to 2327. So this first number is the one that gets changed first. The 1 is going to be changed to a 2 when I click the button. Hold it down because that's the one I want. The little asterisk that shows up there tells me that. Now the second number needs to be a 3. When it's a 3, hold the trigger down until you see the asterisk, then let go. And it goes to the next number, which we want to be a 2. Hold the button down. Asterisk shows up, we can let go. And then a 7. Hold the button down. Asterisk. Now it says press and hold to save. That's exactly what we wanted, so we're going to press the button down and save it. Okay, so now 480 has this as its, well, we'll call it the hammer spring strength, how hard it's going to hit, but really it's called the pulse width. And then we're just going to go on through the settings and change them. So we wanted the next one, we wanted to raise it 15. So 2315, we're going to change that to 2330. Hold the button down until we see the number. There it is, let go. We're going to change it to 2330. So we hold the button down for 2 because it's already what we want. Hold the button down for 3, it's already what we want. This next one we want it to be a 3, so click it one time, hold it down, and then make this next one a 0, hold it down. We want to save that? Yes, we do. And we're just going to keep going through this all the way. So for 560, this goes up 15. We wanted this one to be 2360, so let's hold the button down so we know to edit it. 2 is okay. 3 is okay, so just hold it down to pass them. And then this one, we wanted to be a 60, so 6 and 0 is okay. Press and hold to save. And so I've already programmed all of those. They're all set. I've only got like about, what, 5 more to go, and then I'm done. And then my new settings are set in the gun. That's all there is to it. As soon as I turn off the gun, these settings are already pre-programmed into it. I can just turn on the gun and fire away. The last thing I want to talk about is how you set up a totally brand new setting for your gun. Let's say you're going to shoot some field target and you can't have your gun shooting over 20 foot-pounds of energy. That's not a problem. You can create a whole new setting to where your gun will shoot just a hair below 20 foot-pounds of energy. So you'll pick one of your 12 settings. Let's just say number 12, because I don't use 12 very often. It's the one that I've currently got set up for 38.5 foot-pounds energy. And you want to change it to 20 foot-pounds of energy. Well, you'll take a look at your spreadsheet here. And if you'll notice, the values that you've set up for 18 and this value set up for 21, if you find the exact middle value of all of those and program those in, you'll end up with about 19.5 foot-pounds of energy. And if you wanted it to be a little bit higher, you might bump those values up a little bit correspondingly. I find just keeping track of what my old values were helps me so that I can see what changes I've made and what their effects are. That's how I know that at the lower power levels, if I want it to go up 1 foot per second, it only takes about 1 change in the value of the pulse width. But at higher values, it takes more change to actually see the difference in the velocity you're looking for. I hope this video was helpful, and if you have any questions, please, feel free to shoot me an email, or you can PM me at Airgun Nation. My handle is mmahoney. Thanks for watching. Bye.